Okay, so our third method is to factor using the difference of two squares. So remember, for this, you want to use your first two methods first. So if it's possible to factor by grouping, do that. Make sure if it's possible to factor by GCF, you do that. Okay, so I want you to take a second before we dive in, and I want you to multiply those. So I want you to find the product of those binomials. Okay, so let's pause, and I want you to find the product of those binomials. Okay, so remember, when you find the product of this, you use FOIL. So that's really important. Hopefully you remember FOIL from section 2, okay? So this simplifies down to x squared minus 9. What do you think makes that middle term vanish? What makes that middle term vanish, really? So think about that for a second. Answer that question. So they vanish because the two terms cancel out. So we have a minus 3x and a plus 3x. So they cancel out. Okay. So that's why they vanish, because they cancel out. So now let's look at this formula here. We have a squared minus b squared. When we have the difference of those two squares, it could be factored into these two binomials here. So this becomes these two binomials factored, okay? So what's really important to know is that this a and this b, they're both perfect squares. So they're going to be perfect squares. So that's going to be important to know. So think back to what a perfect square is. So something like 9 or 16 or 225. Okay, so perfect squares. And remember, it has to be the difference here. Has to be the difference. It can't be addition. It has to be subtraction. And then the factored form gives us one addition and one subtraction. So that's really important. Okay, so there's no really easy way to do this, okay? It's simply just memorizing the formula. There's no quick way to know to break it into two groups or find the biggest number that goes into them. Okay, so it's really just memorizing the formula and using it accordingly. Okay, so let's try example number 1. So I want to look at this and think, is k squared a perfect square? Is 25 a perfect square? And am I finding the difference? So I am finding the difference. So I'm going to use this formula, okay? So I'm going to use the formula that tells me it's a and b. So I'm going to figure out what a is. So since it's k squared, a is just then equal to k, right? Because that's our base value. And then b is equal to, what is the square root of 25? It's really 5 to the second power, right? So 5 is my b then. Okay, so I want to identify what my a is and what my b is. Once you get in the hang of this, you don't need to write them out, but it's kind of helpful to visually see it at first. So we have a plus b, and then a minus b, okay? So we'd have it as k plus 5 and k minus 5. Okay, and again, just plug it into the formula up here. All right, so I want you to pause and try example number 2. Okay, so some things here that you may be wondering. Doesn't matter which one comes first, the plus or the minus in the binomials. No, it doesn't matter. You could have on your paper x minus y and then x plus y. They're interchangeable. It doesn't matter. You may also be thinking, what if there's not perfect squares here? If there's not perfect squares, either look for your GCF, because maybe there's a GCF, or it's simply prime. It's just not able to factor by the difference of two squares. Okay, so let's look at it when we have some numbers thrown in here. Okay, so let's look at example number 3 then. Okay, so let's look at example number 3. I want to find what A is. Okay, so this is 9z squared. I want to find the square root of both of those. So I know the square root of 9 is 3, and the square root of z squared is z. So now my A is actually 3z. Okay, so I'm going to plug in 3z for my A value. And then I'm looking at my B value, and it's 4. And I know the square root of 4 is 2. So we have plus 2 minus 2. Okay, so I want you to take a moment and try example 4. Okay, so hopefully you got 7z minus 4, 7z plus 4. Okay, so I want to look at example number 5. So example number 5, it is important to keep in mind our first way of factoring. So I'm looking at this and I have a 4, a to the 4th, and a 36. Is there a GCF we can take out? So we always want to try to find a GCF first. Okay, I'm looking at this and I'm saying absolutely. My GCF is going to be 4. So I'm going to take out a 4 first. And that leaves me with a to the 4th minus 9. Okay. If you didn't take out your GCF, you would still have to simplify your binomials. So our binomials always need to be in the simplest form that they can be. So if there's a common factor between your A and your B values and your binomials, you need to take those out. Okay, because that wouldn't be the correct answer then, because it's not in simplest form. So that's why we always look for GCF first and take that out to get it out of the way. Okay, so now we have some value that's a little higher. We have an a to the 4th. If I have a to the 4th, what's the square root of that? Hopefully you're saying it's a squared. Okay. And now we have, what's the square root of 9? It's going to be 3. Okay. Hopefully you're thinking, if this 3 was a perfect square, could we simplify even further? The answer would be yes. So if this wasn't a 3 and let's say it was a 9, again, I know that's not possible, but for hypothetical reasons, if this was a 9, you would simplify that further. So you want to take the difference of two squares out as many times as possible. Okay, so I want us to look at example number 6, and I want you to go as far as you think you can. Okay, go as far as possible. Okay, so some of you might have gotten stuck after the GCF thinking, can I take the square root of 1? The answer is absolutely. The square root of 1 is just 1. So we could have broken it up, or we should break it up into these two binomials. So if you got to here, you're on the right track. But you're missing something. Look at this second one. Look at this one. This is x squared minus 1. That is the difference of two squares again. So I can simplify this even further. Okay, I can simplify this into x plus 1 and x minus 1. And that's what I meant before by simplifying it as much as possible. So anytime you get these higher numbered exponents or these higher exponents, you have to really watch for that because it's really easy to overlook that you aren't simplifying, okay? So always look to see if you can simplify any further with those higher exponents.